I am Dr. P. Shanthi, Assistant Professor in Mathematics, SFR College for Women, Sivagasi. Welcome you all to this video lecture on network scheduling. Network scheduling is a very important and very essential topic in operations research. The scheduling process are carried out by using CPM and PERT analysis. In this video, let us see the working process in detail. First, let us see what is network scheduling. This is a technique used for planning and scheduling large projects involving many activities. To complete the project in an optimum duration, the activities must be scheduled in order. This is called network scheduling. Network scheduling is applicable in various fields such as construction, fabrication, purchasing, software development, plant maintenance, research and development design, etc. The main objective of network scheduling is to minimize the project duration by identifying critical and non-critical activities and also estimating the probability of completing the project on time. There are two techniques for scheduling. One is CPM, that is critical path method. Another one is PERT, that is project evaluation and review technique. Here, CPM is called the deterministic process because from this method we can get the expected value of minimum project duration time. But PERT is the probabilistic process because by using these techniques we can analyze the probability and possibilities of completing the project on the scheduled time by making use of normal distribution. Now let us learn how to apply the above techniques by illustrating an example. Now let us go through the problem. A project consists of 8 activities with the following relevant informations. Here the activities are represented from A to H and its immediate predecessor relationships are given and estimated duration time given in days with the 3 types of timings: optimistic, most likely and pessimistic time. Draw the PERT network and find out the expected project completion time. Next, what duration will have 95% confidence for project completion? Finally, if the average duration for activity F increases to 14 days, what will be its effect on the expected project completion time, which will have 95% confidence? Let us see the solution. First, we have to draw network diagram for the given data, which consists of node that is represented in circle and activity that is represented as arrow line. In the given project, the activities A, B, C has no immediate predecessor. That means they are the initial activities started at node 1. So that it starts from the initial node 1. Then the activities D, E, F starts from the end of the activities A, B, C respectively. Then the activity G starts at the end of the activities D and E. Finally, the activity H starts at the end of the activities F and G. Hence, H ends with the end node 7. Next, we find expected time TE and expected variance sigma E squared for each activity. For each activity, the optimistic time TO, most likely time TM and pessimistic time TP are given in the problem. The formula for expected time TE is TE equal to T0 plus 4TM plus TP divided by 6. And for expected variance is sigma E squared equal to Tp minus To divided by 6 the whole squared. We calculate the values for TE and sigma E square for each activity as given in the 5th and 6th column of the table. The sample calculation for activity A is provided here for your understanding. Then label the TE values of each activity in the diagram. Now we enter into the main task. Here we use CPM algorithm for forward pass and backward pass to compute the earliest start time EI and the latest finish time LJ for each node. Here there are 7 nodes, so we have to find 7 values in each category. First we find EI. Start with node 1. Set E1 equal to 0 since E1 is the initial node. For remaining nodes, we find EJ values by the formula EJ equal to maximum of EI plus TIJ. Here I indicates starting node and J indicates ending node. For the nodes 2, 3, 4, there is only one activity includes. So, we are not considering maximum of case. But at 5th and 6th node, 2 activities ends. Therefore, we use maximum value for finding E5 and E6. Similarly, we find Li by using the formula Li equal to minimum of Lj minus Tij from the ending node to start node. From the network diagram with EI and LJ values, we observe that the critical path is 1 to 3, 3 to 5, 5 to 6 and 6 to 7. That is marked as double arrow in the network diagram. Because at these nodes, EI and LJ values coincides. That means both must be equal. And EJ minus EI equal to TIJ and LJ minus LI equal to TIJ. That is, the difference value must be equal to the duration of the activities. Hence, the critical activities are B, E, G and H. The remaining activities may be named as non-critical activities. Finally, the expected project completion time TE is evaluated as 19 days, that is, sum of the expected time of all the critical activities. Now we move on to the next question. What duration will have 95% confidence for project completion? That is, by specifying which duration we can give 95% assurance to complete the project. For this, we apply PERT method. We take TS as the scheduled time for 95% confidence. For that, we find the probability of completing the project by scheduled time as P of Z less than TS minus T divided by sigma E. See here, we already found the value of TE, that is 19 days. Now we find sigma E by using the expected variance, that is sigma E squared equal to 9.11, that is the sum of the variance of all the critical activities. By using the normal distribution table for 95% confidence, we get P of Z less than 1.645 equal to 0.95. That is, TS minus T divided by sigma E must be equal to 1.645. From this we get TS equal to 24 days. Hence, 24 days of project completion time will have 95% confidence. For the last question, we have to find the effect of increasing the duration of the activity F to 14 days. Note that in previous discussion, the duration of F is 5. Now see the modified diagram with the new EI and LJ values given here. We observe that the path 1 to 4, 4 to 6, 6 to 7, that is C to F, F to H is also becomes a critical path now. But there is no change in the expected duration of the project, that is T equal to 19 days. Therefore, from the previous discussion, we get TS equal to 24 days. Hence, the project completion time 24 days will have 95% confidence. Therefore, there is no effect on increasing the average duration of the activity F to 14 days in 95% confidence. Hence, for the given project informations, we conclude that the expected project completion time is T equal to 19 days and 24 days of project completion time will have 95% confidence, and there is no effect on increasing the average duration of the particular activity F to 14 days in 95% confidence. Hope you could understand about network scheduling. Thank you, viewers. Keep on learning.